All right, how do we find the area between curves when it looks like this? If you got two graphs where one function starts on top and one on bottom, but then somewhere between there they switch and maybe even switch back a third or fourth time, what do we do then to find the area? Well, there's kind of two ways to handle these types of problems. One is we could break this up into three separate integrals. So we could find the integrals of each one of these separately. So we'd have to find out where these intersection points would be, namely here, if we call that point maybe C, and find that intersection point D. We could do an integral from A to C, where the top function would be F minus the bottom one would be G. We could do a second integral then from C to D, but now they're switched, so we want G first minus f of x. And then a third one from D to B, where f is back on top minus g of x. So that's one way to handle it. And the reason that we would need to switch with this middle one is because here G ends up being the one on top. Now, had we kept them all the same, like had we kept this middle integral as C to D, but we had f of x first instead of g of x, even though that's not the one on top, that would give us the same value as the one down here, except that it would be opposite sign. So this would be the same as the integral from C to D of g of x minus f of x, except that it would be the opposite value. It would end up being negative. It'd be the same amount, but the other sign. So the other way to handle these problems is instead of creating three, we could also use absolute value, because absolute value gives the value, we're not so worried about the negative or positive value, it just gives you the value without the negative or positive. So here it'll give you that positive amount that we want. So let's do this example. We'll show you both ways of doing it. You want to know both ways depending on if calculator would be available to you or not. So if we'd want to find this area for this example here, if we were to do it with two integrals, let's say we didn't have a calculator available, then we'd probably want to go this route. We would look at splitting this up into two separate integrals since the top and bottom functions intertwine there. So the first one from 0 to pi over 4 would have cosine as the top value or top function minus sine as the bottom one. And then they switch. So plus, now we would do an integral from pi over 4 to where it ends there at pi over 2. And here now sine is on top, cosine is on bottom. So if we went through and solved this out, this should give us the answer. We'll do it this way, then we'll show you the other way with the absolute value. So now if we found our antiderivatives for both, antiderivative of cosine is sine. Antiderivative of sine is negative cosine, but because there's a negative there, it kind of be like minus negative cosine. We'll just write that as plus cosine. Evaluated from pi over 4 to 0, plus, now our antiderivative for this next one would be negative cosine. And antiderivative of cosine is sine. And this would be evaluated from pi over 2 pi over 4. Okay, now we got to plug in and see what we get. Sine of pi over 4. I mean, that's one you got to know from like unit circle here. Pi over 4 is the same as 45 degrees here. So that would give us that point where we get square root of 2 over square root of 2. So both sine and cosine values square root of 2 over 2. So this would be square root of 2 over 2 plus cosine of that's also square root of 2 over 2 minus what we get when we plug in 0. 0, that's our straight across value here. That points at 0, 1. Or sorry, 1, 0. So remember that's our cosine value and sine value. And so when we plug in here, sine of 0 is 0, cosine of 0 is 1. Plus, now we're doing our other one here. So if we plug these in, we get that same square root 2 over 2, but these are going to end up being the opposite, so negative minus square root of 2 over 2. Oh, sorry, this is at pi over 2, my fault. I got to do the pi over 2 one first. So if we plug in pi over 2 here, pi over 2 is at 90 degrees. And so at 90 degrees, we got the point 0, 1. So cosine of pi over 2 should be 0. Minus, if we put pi over 2 in for sine, that's going to be 1. Minus what we get with putting pi over 4 in. So if we put pi over 4 in, we get square root of 2 over 2. And sine of that will also be square root 2 over 2. So now if we evaluate this, this should get us to our answer, our exact answer here. Square root of 2 over 2 plus another square root of 2 over 2 is 2 square root of 2 over 2. Minus 1 plus, this is going to evaluate to negative 1. Minus, this one's going to be negative 2 square root of 2 over 2. So evaluating that looks like the answer we're going to get is, oh, sorry, one last thing here. It's minus that negative value. So I forgot. So when we double slash this, this is going to end up being plus. These 2's should cancel. These 2 should cancel. And yep, so we get square root of 2 minus 2 plus a square root of 2 here. So final answer looks like 2 square roots of 2 minus 2. That would be the exact answer. How we can come up with that on the calculator, let's do the same thing, but use that absolute value way. So if you were using one integral with the absolute value, we'd go 0 to pi over 2 of the absolute value of these functions subtracted. And it doesn't matter, since we're doing absolute value, which one you put first and second. I'll just go with the cosine one first, minus the sine one. But if you did sine minus cosine, it should give us the same thing because we're doing absolute value. So on the calculator, let's see what we get here. So go to our math, select our integral one here. Let's plug in 0 to pi over 2. And since we're doing this in radians, make sure you double check that you are in radians here. And then we got absolute value, so hit your math again, go over to the number category, select absolute value, and now we're typing in cosine minus sine. And finally, we got to get in here our dx, and if we put enter, this should give us the approximate value, just to show you that it is the same answer we got if we type in this and approximate it, the exact answer we got. We should get the same thing, and boom. So you can see it does work.